Today's lesson is on dividing polynomials. I've broken this up into two main parts. First, we're going to be learning how to divide a polynomial by a monomial, and then we are going to learn how to divide a polynomial by a polynomial. The two processes are very different, so you need to understand the differences of just how the problem looks. If in the denominator you have just one term with no pluses or no minuses between and making more than one term, this is dividing by a monomial. Okay, so each one of these examples here is dividing by a monomial. To divide by a monomial, the steps are: 1. Separate each term in the numerator and write each term separately as a fraction over the denominator. And then you have a monomial over monomial, and so you're just going to reduce each monomial over monomial like we've done in previous lessons. So I'm taking this polynomial divided by a monomial, and I'm just splitting it up into several different smaller problems. So 5x squared over 5 minus 10 over 5. Each term on the top needs to be divided by 5. Now I can simply reduce. 5 divided by 5, that reduces to 1x squared. 10 divided by 5, that reduces to 2. So we have 1x squared minus 2. Or simply, I could just write x squared minus 2. That would also be correct. Our next example, I take 10xy minus 8x, and I'm dividing everything by 2x. So instead of making one long bar, I'm going to make two smaller bars and make 2x as the denominator for each term in the numerator. And now this is a monomial. Delete. And now this is a monomial over a monomial, which is much more simple to reduce. So 10 divided by 2, that's 5 in the numerator. X divided by x, that divides out, and I still have y. I don't have anything left in my denominator, so I could put over 1, but that's not necessarily helpful, so I'm just going to erase that and just write 5y. 8 divided by 2 is 4, and the x divided by x divides to 1. And I can leave it like that. 5y minus 4. Our next example, I have a squared b squared minus a to the fourth b cubed divided by negative ab squared. So each of those terms, there's two terms, and each of those terms is going to get divided by negative a b squared. Alright, so now I'm going to reduce. A positive divided by a negative is going to turn out to be a negative. A squared over a to the 1. I'm subtracting my exponents and getting a to the 1. I don't really need to write to the 1. I can just write a. And then b squared divided by b squared divides out nicely. Negative divided by negative turns out to be a positive. A to the 4 divided by a to the 1, I'm going to subtract my exponents and get a to the 3. B to the 3 divided by b to the 2, that's going to subtract to get b to the 1. Now, I don't really need the 1 in the exponent. Any letter without an exponent implies a 1, so I can just leave my answer as negative a plus a cubed b. Our next problem, I have 11a squared b squared minus 33ab. I'm dividing those by negative 11ab, so now I'm just going to put two division bars, and each term is going to be divided by the monomial, negative 11ab. And then negative 11 divided by negative 11 is negative 1. Subtract my exponents, I get a to the 1 left over in the top. Subtract my exponents for the b's, I get b to the 1, leave it in the numerator. I'm going to erase my 1's because I really don't need them. Negative 33 divided by negative 11 is positive 3. The a's divide out because there's 1 minus 1, that's 0, so you don't have to write them. The b's divide out to 1, but I don't really need to write it because if you wrote multiplied by 1, well, 3 times 1 is 3, times another 1 is still 3. So writing those aren't really all that necessary. Unless there wasn't anything there, then you'd have to write the 1. So let's do some more examples here. I have 6x squared a plus 12x squared b minus 6x squared c, all divided by 36x squared. So there's now 3 terms in the numerator. Each of those 3 terms is going to get divided by my monomial denominator. And then I reduce. 6 over 36. Because the 36 is bigger and the bigger one's on the bottom, when I reduce 6 divided by 36, that leaves me with 1/6, not 6. A lot of people want to write 6, but that would only be if the bigger number was on top. Since the bigger number is on bottom, the remainder 6, once you divide, ends up still on the bottom. The x squared divided by x squared divides out to 1. I don't need to write it because I already have a 1 here. And then the a is left on top, so I have 1a over 6. 12 over 36, that can reduce by 12, so if I divide the top by 12, I get 1. Divide the bottom by 12, I get 3. Again, the x squareds divide out, and my b doesn't have any terms to divide out, so it's still left on top. Minus 6 over 36, that can reduce by 6, so 6 divided by 6 is 1 in the numerator, 36 divided by 6 is 6 in the denominator. The x squareds divide out, and c is still left in the numerator. So this is my answer. Just because I'm reducing doesn't mean that I might not still have fractions in my answer. Another way of writing this, I could have just written a over 6 plus b over 3 minus c over 6. The 1 coefficients aren't necessary, but they're not going to hurt anything if you have it there. Our last example for monomials, again, there's no pluses or minuses in the bottom, in the denominator. So I'm going to take 12ax minus 9bx plus 18cx, and that's 3 terms, all of which are divided by the monomial denominator 3x squared. Now I divide. 12 divided by 3 is 4 in the numerator because the 12 is bigger. 12 divided by 3 is 4, 3 divided by 3 is 1, but I don't necessarily need to write the 1 in the denominator unless there's something other than 1. A doesn't have any partners, so that stays again in the numerator. One of the x's cancel out, so you have 1x divided by 1x in the bottom. So you have 1x in the numerator divided with 1x in the denominator. That leaves you with 1x still left in the denominator because there was more x's to begin with in the denominator, so the leftover x's should still stay there. 9 divided by 3 is 3 in the numerator. B is in the numerator, and one of the x's divides out with one of the x's. You still have 1x left, and because it was the larger amount was in the denominator, it stays in the denominator. And the last one, 18 divided by 3 is 6. C doesn't have anything to divide out with, and one of the x's divides out, so you're left with an x in the denominator. So each of these is like its own little monomial divided by a monomial problem in and of itself. But monomials over monomials aren't so bad. We've used those from back when we were learning about integer exponents. And that is how you divide a polynomial by a monomial.